The next term to understand is the mole fraction. See, molality and molarity both are very good terms, but the problem with them is that they only talk about the number of moles of the solute which are present in the solution. They never talk about the number of moles of the other component, which is the solvent. So in order to have a comparative account of the number of moles of both these components, the mole fraction term is used. As the name suggests, fraction, it is out of 1. So it is basically the ratio of the number of moles of a component to the total number of moles of all the components of the solution. Like if A is your solvent and B is your solute, the Na are the number of moles of solvent, Nb is your number of moles of solute. So the mole fraction, which is expressed as chi of the solute, will be the ratio of number of moles of the solute upon the sum of the number of moles of both A and B. So this is the total number of moles of all the components. This is the number of moles of the particular component whose mole fraction is to be determined. So it is the ratio of the number of moles of a component upon total number of moles of all the components of the solution. Similarly, chi A, the mole fraction of the solvent, will be the ratio of number of moles of the solvent to the total number of moles of all the components of the solution. And what is interesting is that if these two terms are added, what we will get is chi A plus chi B will be 1. Since it's a fraction out of 1, always remember the sum of the mole fraction of the components of a solution is always 1. So if we know the 1, we can find out the other one by subtracting it from 1. Now let us do a numerical in order to make this concept more clear. Now let us understand mole fraction with the help of a numerical. Find the mole fraction of NaOH in an aqueous solution having 20 grams of it in 200 grams of solution. See, in this numerical, therefore, weight of the solute already given is 20 grams. But how much is the mass of the solvent? See, the mass of solution is 200 grams, out of which 20 grams is your NaOH. So your solvent water is 180 grams. So once we know their respective masses, let us find out the number of moles of the solute NaOH first. It will be its mass by molar mass, 20 by 40, because the molar mass of NaOH is 40 grams per mole. So it will be 0.5. Similarly, the number of moles for water will be its mass upon its molar mass. It's 180 by 18 because water is 18 gram per mole. So it is 10 moles. So once we know their respective number of moles, the mole fraction of NaOH will be the number of moles of NaOH upon sum of the number of moles of solvent and the solute. So it will be 0.5, 0.5 plus 10, 0.5 upon 10.5. So it is 5 by 105. So it's 1 by 21. So this is the mole fraction of the solute in the solution.